So what's up, everybody? Welcome to week 13, and gonna wait for some people to join in here, and then we'll start going over some math questions. Well, I will go over specific math questions that people are requesting. Otherwise, in the meantime, I will just go over a select few math questions of my choosing. But my default is calculus, so that's what I'll go over. Now let me see here. Let me just look for a good question. And let's see. What is a good question here? Okay. So I have this one. So we have find the sum. Well, I'll write it out, then we'll read it, because it's difficult to do both at the same time. So find the sum of. All right, we have A and B. And now such that. And now here's our function. So we're going to have f of x equals 2ax squared plus bx plus 3. And then what we want is a situation where we have a relative extremum at 1, 2. Okay, or extrema at 1, 2. Either one. All right, so for this one here, what I would do, and let me just scan here. So I just, I have to schedule these further in advance. I made the mistake of just scheduling it shortly before I started the stream here. So we'll see if we get a lot of people this week. But I think if this is week 13 though, so I've been consistent 13 weeks in a row with having this live stream going. So let's just get some different colors here and we will see. But to anyone who joined in, hello and thanks for stopping by. So if we want a relative extremum at this, notice this is a polynomial function. So where my head is going right away is I'm thinking, okay, we want f prime of x to equal 0. So f prime of x first is 4ax, because we're doing 2 times 2a is 4a. X to the power rule, we're doing 2 minus 1, and then we have plus b. So this is what we want to set equal to 0. 4ax plus b is equal to 0, so this is going to occur at x equals, and we would have negative b over 4a. So we're just doing minus b divided by 4a. So that's the first part here. Now, what we want to happen also is we want f prime of 1 to equal 0. So that gives us another situation here. F prime of 1 would be equal to 4 times a times 1 plus b to equal 0, which here is going to tell us if this is true. So let's think about this very carefully. So what we have, find the sum of the values a and b such that. All right, so this is an interesting question. So I already threw myself one that's got me in a little bit of a loop, but let's think about this carefully. So find the sum of the values here. Let's think about this. So once again, f prime of x, we set it equal to 0. This is going to occur at x equals negative b over 4a. All right, the next thing that we want, oh, I see. So this is giving us this equation here. I actually could have just stopped at this part. Okay, so I'm going to circle this. This is big. Okay, this we're going to need. But the second thing we need is we need the function value at 1 to equal 2. And the function value at 1 comes from the original function before the derivative. That has to equal 2. So this is going to give us 2a plus b plus 3 is equal to 2, which would tell us 2a plus b equals negative 1. So here's our second equation. All right, so now we're going to combine the two. We have 4a plus b equals 0. We have 2a plus b equals negative 1. So for this one, there's a few ways we could go forward with this. I'd probably multiply this row by negative 1. We have a little system here. And we're going to get this, and that's going to give us negative 2a minus b equals positive 1. Now you add, and you're going to have 2a equals 1, which tells you a is equal to a half. And if a is equal to a half, we could plug into either equation. Let's say we plug into the red one. Well, then what we would have here, we would have 2 times a half plus b is equal to negative 1. So that's 1 plus b equals negative 1, which tells us b equals negative 2. But the original question asked, find the sum of a and b. So the sum, a plus b, is going to be equal to, we're going to have a half plus negative a half, which is equal to 0. And okay, let me just double check something here, because this book does have an answer key. As soon as this unfreezes, unless saying 5 halves here. Oh, b is equal to negative 2. Okay, b is equal to negative 2. Oh, Xiaolong, hello. I gotta work this out. Let's see. So that's negative 2. Why did I say negative half? I think it's after a long day. Sometimes my brain is fried. All right, minus 1 on both sides. B is equal to negative 2. But then negative 2 plus this would be negative 1.5. They're saying it's choice B. Now I got to go through this again. I'm going to go through it once more just to double check. So we have f of 1 is equal to 2. That's still correct. So that's 2a plus b plus 3 is equal to 2. So 2a plus b equals negative 1. Okay. So that part is good. And now, okay, so this part is good. F prime of x is definitely 4ax plus b, and f prime of 1 equals 0 would give us 4a plus b equals 0. Yes, and now multiply by negative 1. All right, now the thing is, the answer key is telling me something else. So what I would do, if I'm like, wait, am I right or is the answer key right, is I would plug in our values of a and b and c. See if this is the right thing here. So what we had was 2a plus b equals negative 1. So b equals negative 2. So those values I'm feeling confident with, but let's see. Capital F of x equals, just to double check, 2 times a is equal to a half. So that would give us x squared minus b is equal to 2. So we have minus 2. I'm sorry, b is equal to negative 2. So I'd have minus 2x and then plus 3. So a few things to check here. F of 1 is 1 minus 2 plus 3, and that is definitely equal to 2. So that checks out. F prime of 1, in this case, f prime of x would be 2x minus 2, and f prime of 1 would be 2 times 1 minus 2 equals 0. All right, so we're definitely correct, because when I plug back in here, yeah, that definitely checked out. So yeah, don't always trust the answer key is the moral of the story. So I don't want to just, yeah, kind of just randomly go with their answers. All right, so unless there's any specific questions, I will continue solving random math questions. But let's see. We have, oh, more people. So hello to anybody just joining. Welcome to week 13. And once again, specific questions are strongly encouraged. Indefinite integrals. Could do some of those. Maybe I'll practice some of the stuff I've been teaching lately. Those are, I'm just looking for some good questions. Random definite integrals. All right, let's see. Oh, here we go. This is a nice one. Okay. So look at this. This is Oh, how about this one? 5x to the third plus 40 is equal to the integral from c to x of f of t dt. And we want to find what is f of x. So for this one, we could just take the equation and take the derivative of both sides. Now, one thing to note here, side note, is that when you take the derivative with respect to x of an area function like this, it's equal to f of x, mainly when you have a constant and a variable. So this is going to give us 15x squared plus 0 equals the derivative is going to be f of x. Okay, so that's this here. Now let's say we want to find c. So now part B is find the value of c. Okay, so for this, what we would do is, now that we have an explicit function equals the integral from c to x, just know f of t, if this is f of x, then that would tell us f of t, the integrand, is 15t squared. So this would be 15t squared, and now we tack on dt. So now ftc1, the antiderivative, would be 15t to the third over 3, and we're going from c to x. The right side stays put. So now we've got 5x to the third plus 40 equals, and this is going to simplify to 5. So I have 5 times x to the third minus c to the third power. So this is 5x to the third plus 40 equals 5x to the third minus 5c to the third. These terms are going to cancel. And now here we divide, we have 40 equals negative 5c to the third. Divide both sides by negative 5. And now you've got c to the third equals negative 8. And you can take the cube root of both sides. C is equal to negative 2. All right. So that's a nice little question there. I like that one. I don't think I've done that one before. So, cool. All right. So let's see. Oh, now I have a few more. We had 10 people visit. Very nice. Says we have like, I think 3 or 4 concurrent viewers. So to everybody else who just joined, hello. I need to do a better job of advertising this. I keep talking about the behind the scenes of YouTube, but my goal down the line is to, I don't know. People keep telling me if I want to target high school, I got to get on TikTok, but I don't know. I think I posted like a few things on TikTok, like math related, but I'll get out there more. So it's a work in progress for sure. Okay. I think everybody's ready for a break though, is what the vibe I'm getting. I will, at some point over the break, I will take a week off. Like I think it's healthy to break the streak every now and then. So while we're all on break, I'll probably, wind up taking a break for one of those Wednesdays. What is going to happen one of these weeks, I should point out, is I'm going to switch to Regents practice. Like I'm going to be doing just algebra, just geometry, or just algebra 2. So that day is definitely coming. And for that, I just have to brush up on one more topic. I have to brush up on the probability and stats. Like, for some reason, I've never taught algebra 2. So, I know algebra really well, but like the non-algebra stuff, I have to brush up on. I'm very rusty. So, all right. So let's say we want to find g of 0. That would be this. And integral from 0 to 0 is 0. Okay. Now let's see. Does part B. Does g of 2 equal g of negative 2? Is this true? this is also a question. Does g of 2 equal negative g of 2? All right. So for this part, what I know is I always look at this formula. The equation of a circle. And just know when it's a square root like this, that's when they essentially, like I'm thinking of this equation here, and what this is reminding me of, it's reminding me of, make a space over here, like x squared plus y squared equals 16. Okay, which is a circle centered at the origin, radius 4, all around. And if you do y squared equals 16 minus x squared, you take the square root, you get two equations. Y equals this, and you get y equals minus this, plus or minus. So when you're looking at the plus, the positive radical, that's the top half of the circle. So for the rest of this question, what I'm thinking of is I'm thinking of our function of t here on the inside. Like let's say you call this f of t. F of t is going to look like this. So it's going to go out to 4, to negative 4, up here to 4. It's a semicircle. So the full area of this is pi times the radius squared divided by 2. So this is 8 pi. And since it's symmetric, this piece would be 4 pi, and this piece would be 4 pi. So I'm just getting ready for the rest of the question here. So now g of 2. G of 2 is going to be the area from 0 to 2 of this. Now they don't actually want to know what it is. Okay, they're just asking you, is it equal to g of negative 2? And g of negative 2 would be the integral from 0 to negative 2 of this. Now, the problem I see right away with this is that if I flip this, I have to make the integral negative. Okay, so I have to make the integral negative. So g of negative 2, like whatever this area is here, up to 2, like let's say I call this piece k. So this is equal to k. Then at this location here, this would also be equal to k. So then what I could say is that g of 2 is, let's say, equal to k, but g of negative 2 would be equal to negative k, because from negative 2 to 0, when I go from left to right, I treat this as positive. But when I'm backwards here from like 0 to negative 2, the smaller numbers on top, I personally like to flip it and make this negative. So these are not equal. So this is like, no, they're not equal. But g of 2 is equal to negative g of 2. That's definitely true, because negative g of negative 2 would be equal to negative negative k, which would equal positive k, which matches this. Okay, so this is a yes. Those are equal. Okay, oh, Clumpy, good evening. Thank you for joining. Always happy to have people join, and comments are always appreciated. So thank you for getting the chat going here. All right. Oh, what are g of 4 and g of negative 4? All right, so g of 4 is the integral from 0 to 4 of the function. All right, you see this is coming in handy now. From 0 to 4 we said was 4 pi. It's the quarter circle with the radius 4. G of negative 4 would be the integral from 0 to negative 4 of our function. And this is the same thing as negative integral from negative 4 to 0. And from negative 4 to 0 is also 4 pi. So this one would be negative and then 4 pi. All right, so a nice little question to look at. So yeah, anyone just joining here, says we have 6 concurrent viewers, like 6 of you here right now. So thank you for, oh, now 5. But thank you, the people who are here, for joining the live stream. And if you have questions, you could ask it in the chat, or you could always send the email to vinteachesmath@gmail.com. Okay. So otherwise, I'm going to just keep doing random math questions here. All right, let's see. Something. How about something, I don't know. wacky. Maybe I should take some like easier questions, like just do like derivatives or just integrals. I don't know, unless people in the chat. Oh. Yeah, you could. Oh, these I'm just doing random until people actually send me questions. Because I don't want to just stand there and just talk about random life stuff. It's easier for me to just talk about math because that's my jam. That's what I know. Maybe I should go backwards and do algebra because maybe all the algebra people coming here are just getting scared away. Like, I don't know. But yeah, if you want to email a question or if it's something that you're able to type, either one. As long as it's not like Calc 7 or something I'm out of practice with. Like, I have no problem saying if I don't know how to do something. So, yeah, that's just any specific questions you can send my way. All right, let's see. Maybe I'll look at a... Oh, this one looks nice. Let me just... All right, so for anyone who has me, something from the packet of fun, e to the x plus e to the negative x over e to the x minus e to the negative x, and dx, of course. So these, u is almost always the bottom. So u equals e to the x minus e to the negative x. Now, when you take the derivative of e to a constant x, that is the constant times e to the kx. So this, we'd have du equals derivative of e to the x is e to the x. And now we have minus the derivative of e to the negative x is e to the negative x times the derivative of the exponent is -1. And if we multiply by -1, that changes this to a plus. Now we tack on dx. But notice the top is e to the x plus e to the negative x dx. So now our new integral, we could just write du across the top, and the bottom is equal to u. So natural log, absolute value u plus c, which is going to give us this. Okay, there's our space, and that's e to the x minus e to the negative x. Cool. All right, let's see here. All right, so far no questions, so I will just keep answering some questions of my own. Maybe if no one's here, I'll just learn some new math. I mean, that's also, I mean, not if no one has specific questions, I'll learn some math that I wanted to brush up on. I got to take that textbook back with me then. Okay, let's see. So what question are we going to do? Ooh, all right. This one looks annoying. So let's see. Oh, my fountain pen. Okay, so we want to evaluate this. The integral from 0 to f of x. I'm sorry, from 0 to 6 of f of x dx equals. And here is our f of x. You ready for this? I don't know. Would that be interesting? That would be cool. Learn math on stream. Like narrate my thoughts. Because I think people sometimes, I could just teach random stuff, but people might appreciate, like, how do you actually learn math? Like, is there anything I'm doing different? And my main thing when I learn math is I personally, and this gets harder to do later, but like I really try to understand why it's working. I'm really committed to getting the concept down. I mean, sometimes definitions, like you just have to know that a triangle has 3 sides. So there's no like concept as to like why triangle means 3 sides. Like you might be able to say, oh, a tricep, that muscle has 3 parts to it. Tricycle has 3 wheels. But like other than that, you kind of have to just know certain definitions. But knowing like why this stuff works, being able to explain it is how you really, really understand it. So There's certain parts of Algebra 2 I want to relearn. And then over the summer, my goal is, because I'm going to be able to send both of my kids out of the house, like they're going to go away for parts of the day. So I, plan on getting a lot of work done in that respect over the summer. Just constantly adding content. My goal over the next month is, it's been tough, with my two kids, but I've been adding a lot of regions videos for New York. So, like kind of branching a little bit away from calculus, like trying to cover all the math, because, as much as I love teaching calculus, it is, more people take, I would say, Algebra 1 at the high school level than they do take calculus. So that's just something. All right, let me draw this a little bit more quadrant 1 heavy, because that's where this is located. But yeah, I was just thinking out loud that eventually I'm going to have to branch and do some of the other stuff. Why am I... Okay, maybe, I'll go more here. I'm just like investing in my future happiness here. So y equals x looks like this. All right, and it's open here. And it stops at the point 2, 2. So this is like the y equals x piece. And then if I were to graph, let's change colors here. Here we'll go, I don't know, pink, and we'll go orange. All right, y equals 1 brings us down here. So now it's open here, and then it goes all the way to when x equals 4. Okay, and then if you think about this part, like what I think of here is if I had like y equals 1/2 x, and I plug in x equals 4, even though technically I'm not allowed, I get y equals half of 4, which will tell me y equals 2. All right, so that's going to bring me back to here. And now let's extend this. What color was that? Was this color? Cool. All right, I'm glad I remembered the color. So then 6, if I were to plug in y equals half of 6, that would send me to 3. So that's going to bring me up like one more notch here like this. Okay? So our area that we're finding, if we look, we're going to be looking at this area from 0 to 6. So like this, well, let's make this a different color. So we're going here. So this triangle, this rectangle, because that's a horizontal line, and then this trapezoid. So it's a nice little question. I like this one. All right, so here, the integral from 0 to 6 of f of x dx with just geometry is the area of this first region. Call this like region 1, region 2, and region 3. So we're finding the area of region 1, which is a triangle. We have 1/2, the base is 2, times the height is 2. Okay, plus, and now we've got the base is 2, times the height is 1. So this is region 2, which is a rectangle. And then the third one, the area of a trapezoid for region 3, just know the area of a trapezoid equals 1/2 height, base 1, plus base 2. So we have 1/2, and just know the bases are the parallel sides. So the height is actually this segment here from 4 to 6, which is 2 units long. And now this vertical distance is 2, plus the other vertical distance is 3. And now we simplify. Half of 2 is 1. So this is equal to 2 plus 2 times 1 is 2, plus half of 2 is 1, and we're adding 5, so this should work out to 9. Okay? Oh, my kids are 1 and 3. Yeah, my kids are very little, very helpless. So they, I'm pretty much like, when I'm not doing YouTube or working, I'm in like full-time dad mode. So most of like nowadays, like I make my YouTube videos like mostly when my kids go to sleep. Like I try to do it during the day sometimes, but like I'm hanging out with them for most of it. There's not really a lot of time during the week where I'm making videos where my kids are running around. So it's usually at night that I do this. In a weird way, like this work is like me unwinding. I don't know why. Like, I feel satisfied knowing I'm creating something. So YouTube has been like this, like, you know, it's becoming this like lifelong project for me, that my goal is to just have is like, why am I doing this? I want as much quality math instruction out there for people. Like, I really take the quality of instruction like very serious, that I want to make it like as understandable as possible for everybody, you know, like no matter what your skill level is, like the kids who, you know, really struggle in math, the kids in the middle, and then, you know, the kids at the top. Sometimes like even the kids at the top don't get the attention they need. You know, like what happens a lot of times is, you know, the teacher gives out work and the kid at the top just like flies through it. And then they're just like sitting there like, all right, and like, now what? So even for them, like I always have that in the back of my mind, that I want to make it challenging enough that like everybody will struggle and get something out of the lesson. So yeah, that took me a while to like really figure out like who, you know, like you're coming up with your reason for why you do something. But in the beginning, I did YouTube videos like just because, I don't know, I was like, all right, let me just do this. This seems like it'd be fun. And I really didn't have like a solid purpose, but I was like, oh, let me just make YouTube videos and see where it goes. And it helped me find a job. So then like, but then what YouTube became for me was it became kind of like my validation with my work, because, you know, we get evaluated at work. We have supervisors, but to be honest, the feedback that I respect the most, or that I get the most out of, is the feedback that I get from all of you, you know, the viewers. That is like what I like truly value the most when it comes to feedback, because it's honest. You know, like the people, especially students, like in my school. I mean, don't get me wrong. If somebody's watched like 20 of my YouTube videos and they're like, "Hey, why don't you try this?" Like, yeah, obviously I'm taking their comments very seriously. You know, it's like sometimes you'll just get a random hater and they'll just say something ridiculous, like, "Oh, didn't learn anything. Video sucks." Like, bleh. Like, I'm like, all right, wow, great. You know, great comment. Thank you. They weren't very specific. I mean, if the video was just trash, like, I'll agree with them. But there were times where like the video has like 99% thumbs up, and then like that one person comes in and that hates it, and it's like, all right, like they're probably the odd one out. So like that's something I look at. If the like to dislike ratio is high, then I'm like, all right, that was a good video. And if I get a lot of thumbs downs, it's like, okay, what can I fix? Like I'm always like very critical of like what could be done better. Even at school, I constantly change my lessons up. You know, if there's a question that I don't like, or even a lesson, like I'm planning on next year optimization, I'm throwing my old one out. I'm throwing out the old lesson, and I'm going to like go back to square one, because I just don't think it was like that effective. Like no one really learned how to do optimization, or maybe I just need to do a second day on it. So I'm really trying to, like, the next videos I've been putting out there, I'm like really thinking carefully about which questions I put out there, because I want people to get something out of them. And you know, now what I'm doing more is like putting like an easy, medium, like difficult, and like sometimes an insane question out there, because I think they're more entertaining. But Maria, hi. Thank you for your math help. I appreciate the comment, and I'm happy to help. If you have any specific topics that you want me to cover, whether it be algebra, geometry, algebra 2, trig, precalculus, calculus 1, calculus 2, over the summer I want to start relearning calculus 3, because I want to be able to help my students once they graduate. Like, I think that'd be fun. Like, I don't want to say like, all right, I have nothing left to teach you. Like, it'd be fun to teach them for like their first semester of college too. I think that'd be really cool. So that's my goal over the summer, is to start relearning my old math. So yeah, time permitting though, of course, I'm going to take it one subject at a time. My school does not offer multivariable calculus. There was a user here not that long ago that is currently taking multivariable calculus. I know some of the high schools across the country do offer it, so that's just something cool that, you know, hypothetically, like if that ever wound up in my school, I would love to be able to teach it. So yeah, just throwing that out there. All right. Well, if no one has a specific question, then what I will do is I will just pull up a new math question. So let's see. Maybe I'll go further ahead. Should I go to applications of integrals? Oof. That might... Maybe I'll go backwards. Maybe I'll go back to derivatives. Let's see. Because if I didn't teach that to my current group yet, I think I might terrify people. Unless, I don't know, if people want a sneak preview of the next topic, that's also okay. But once again, yeah, if you have something specific you want me to cover, I'm happy to help. All right. Or just those random, ideas or general comments are also appreciated. All right, so let's see here. Maybe, this is Simpson's rule. No, I'm not going to do that. How about, I don't know, maybe I'll do algebra. I haven't talked about algebra in a while. I could always do that. Let's see. By topic. Or geometry. Geometry could be fun. Is there any ridiculous geometry questions? Let's see how people remember geometry. How about arc length? I don't know if you all remember that. Oh, then I'm going to need a calculator. Yeah, that's going to be... I want to be able to do math like that doesn't need a calculator. But hang on. I will flick off the background real quick. Just so I can get the calculator open so it doesn't like show my desktop and all that. So let me do that. Just so it is ready. All right. Here we go. Oh, perfect. All right, so the calculator is ready to go. Oh, that degrees minute stuff? Yuck. Yeah, they don't teach that anymore. That's some old stuff. Oh, wow. This question looks ridiculous. Yeah, see, sometimes like the old math can be very tricky. But I like tough questions. All right, so this is the one we're going to do. So let me get this screen back up. Okay, and let me, here we go. Okay, so the font is like not that clear, but just bear with me here. So we have a regular hexagon is inscribed in a circle. All right, so there's our circle. And, oh wait, does this recognize when I draw oh, that's so cool. This software wins. Okay. Wow, if they could recognize a hexagon though, let's see. So let's change colors. So I'm trying to imagine. All right, it's like 1, 2, 3, 4, 5, 6. All right, that was pretty awful. 1, 2, 3, 4, 5, 6. Also awful. I really want to make it perfect. All right, that's also bad. I'm going to just freehand it. One line at a time. Okay, so this, 2, and then like maybe here, 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 and here. 1, 2, 3, 4, 5, and 6. Okay, so it's regular, which means all these sides are the same. All right, now what they're asking is what is the ratio of the length of one side of the hexagon? So that's this here, one side of the hexagon. What is the ratio of this to the minor arc that it intercepts? Okay, the minor, so what is the, all right, so the length of a side. Now, one thing that jumps out at me is this, that these triangles here, if you chop it up, is going to make 6 equilateral triangles. How do I know they're equilateral? So these are 6 equilateral triangles because well, we're in a circle, and this is regular, so all of these are the same. And if all of these are the same, that means these angles here are the same. And if those angles are the same, well, let's think about this carefully. What we can say, I don't know if you all remember this formula, n minus 2 times 180 is the sum of the angles. But if you divide it by n, that tells you the measure of each angle. So each angle, if there's 6 sides, 6 minus 2 times 180 divided by 6 is 4 over 6 times 180, which is 2/3 of 180, which is 120. Okay, so these entire angles are 120. But what we can say here, since all these angles are going to be the same, okay, all of these angles here are the same, so all of these triangles are congruent. And if all of these triangles are congruent, that means their corresponding sides and angles are the same. So we have 6 congruent triangles. Now, let's think about how do we know that? Oh, because if they're congruent and this angle is 120, the big angle, like this is 120, there we go. Then these are all 60 degrees. And that means those are all equilateral. All right. So a little geometry chat. I like geometry. I teach it this year. And I feel like I'm really getting back into it. Which means all of these central angles are 60 degrees. So the measure of this arc here is 60 degrees. But in radians, that would be pi over 3. So let's think about this carefully here. Oh, well, you know what? This is equal to the radius. So let's think about this carefully. What is the ratio of the length of a side of a hexagon to the measure of the arc that it intercepts? Oh, okay, I got it now. I think I see it now. All right. So whatever r is, okay, so this like radius is r. The circumference is 2 pi times r. But the arc that we're looking at here, like if we highlight one of these, so one of these pieces is like 1/6 of this. Okay, so the arc that we want is basically 2 pi over r divided by 6, which is pi r over 3. And they want, what is the ratio of the length of a side? The side of the hexagon is r, to the minor arc it intercepts. That's pi r over 3. So this is like the same thing as r over 1 over pi r over 3. So that was a bad 3. So this now becomes r over 1 times 3 over pi r. 3 over pi. Choice 3. Cool. Geometry. That was a fun question. Yeah, see? So that one I didn't... Oh, improper integrals. Sure. Yeah, I could definitely do one of those. So let me find some improper integrals. Maybe I'll go to, I don't know, the online math notes site. Or I could just scroll here. Is this where I got... Yeah, this is where I got the other ones. Let's see. Oh, here we go. Maybe here? No, let's find the derivatives. Let's see. I have to find one that actually has it. Oof, that one looks bad, but all right. So at Dory, I will, and hello, of course, too. But I will find one. As soon as, maybe here they have one. X sine X. Yeah, I want to make sure I get one. Any day now. Wait, did they not have... Oh, here we go. Actually, no, that won't do it. Do they really not have an improper? How are they going to have a practice test and they don't have an improper integral? All right, I'm just going to have to go looking for them. Maybe I'll find, do I have an old, I'll see if I have like an old calculus textbook out. No, I don't. All right, so I will just go. Let's see. I'll pick a random site. Maybe. Okay, so here. Improper integral. So 0 to 2 of 2x over x squared minus 4 dx. So with improper integrals, I always recommend going on a side quest. But right away, when I look at this without a calculator, I see the upper limit is a problem. Okay, so this is going to have... I could use a calculator here, which, speaking of, I do have a calculator. Let me just double check the... There it is. Okay. So if we were to kind of look at what does this thing look like? All right, I got this new mouse and it's nice, but it's very loud. I don't know if this sound is like nice to listen to or if it's annoying. So sorry. Maybe my next mouse, if I buy another one, I'll get a silent one. This one clicks very loud. All right. So that's what the picture looks like. So we're going from 0 to 2. So this space here. So here, like basically what I'm looking at is we have vertical asymptotes at -2 and +2. And so we're here, but once again, if I want to see just that piece from -2 to 2 is kind of like a tangent type graph, but like inverted. So it looks like this. Okay, and this is from 0 to 2. So what we're basically trying to find here is like this area. But the question is, does it spill out to infinity or does it get to the asymptote fast enough? So for these, what I always recommend doing is do the antiderivative first. And this, I would do a u sub. So we have this, du is 2x dx, which completely replaces the top. You see how like there's 2x and there's dx? That means I could just write du over u like this. Okay, so for this part, what we would have is we'd have natural log absolute value of u and plus c if it was indefinite. So this is natural log of absolute value x squared minus 4 plus c. Okay, now the reason why this is a side quest, but the reason why we do this is so that now when we rewrite this integral, so this is the original. Remember, the vertical asymptote is at 2. And if I was doing this without a calculator, like what I'm doing in my head is I plug in x equals 2. I plug in 0 and I'm going to get 0 over -4, which is 0. Like doing that in your head is like, you know, fine. And then if you plug in 2, you're going to have 2 times 2 over 2 squared minus 4, which is 4 over 0. And this is undefined. Okay, so that's why I know 2 is the problem. So the piece that is the problem, this, is what I am going to replace. So I'm going to say the limit as, let's say, the letter b approaches. So I'm going from 0 to b instead. And b, we're approaching 2, but we're on the left side of 2. Like this. And then I have 2x over x squared minus 4 dx. But the side quest, the reason why I like to go through the side quest first is that now we're going to just do the antiderivative. Here like this. And we're going from 0 to b. So we're using now FTC1, or the fundamental theorem of calculus. Some people call that one FTC2, but there we go. All right, add more. So now what we have is this is equal to the limit as b approaches 2 on the left of, and we're going to have natural log of b squared minus 4. Oh yeah, absolute value, of course. Minus natural log, absolute value. And we are going to have, here we have 0 squared minus 4. Now, if we think about this, this is going to equal, this is where number sense comes in. Where this is heading, let's say know your graphs. Okay, as b approaches 2 on either side, notice like b is being squared. So when I think of that, I'm thinking of like, all right, natural log of like 2 minus squared minus 4, but absolute value like this. This is heading towards, like, as we get closer to this is getting close to 4. Okay, so then it's kind of like we're taking natural log of like a small positive number. You know, because think about it. Let's say you did like 1.99 and you square it. This is like almost 4. All right, this might give you like, let's say 3.98. All right, this is like roughly like 3.9, whatever. So if you did an absolute value of 3.9 minus 4, you see how this is like a small positive number. So that's my idea, that I have like a small positive number. And then if I think about, this is no calculator. What does natural log look like? Natural log looks like this. So as I like take natural log of like a small positive, that's kind of like taking natural log of 0 from the right side. I'm heading down to minus infinity, like this. So that's how I know this is heading towards minus infinity minus a number. This is just going to minus infinity. So we could say, therefore, the original 2x, I'm going to forget that. Wait, I think I have it on a separate document here. So therefore, the original integral from 0 to 2 of 2x over x squared minus 4 dx diverges. Okay, this diverges. So that's that. Yeah, something to be careful with. All right, so little limits to tack in there. All right, so let's see, any other questions? All right, what I think I'm gonna do for tonight, I'm gonna call it, because we're like nearing the 1 hour mark. But to anybody who stopped by, thank you. I appreciate the questions. And some people just saying hello. But thank you for stopping by. And yeah, happy studying, happy practicing. And I will see you. Yeah, I'll see you all next week. I will do, let's see. Yeah, I'll do another one next week because it's like finals week for colleges. But then I'm probably going to take with the 21st, no, I could do like a 21st one. I'm probably going to take a break on the 28th. Okay, so yeah. But have a good night, everybody. Thanks for coming by.